Alright, ladies and gentlemen, hello, this is Shahien Shahkar, and just going to be going over using square roots to solve quadratics. Oh, yeah! Here we go, let's going to solve this out. Now, we're used to solving if we have the root of 64. The root of 64, we know, is going to be the root of basically 8 times 8. And the way square roots work is that if you have two of the same number multiplying, he gets to pop out. Okay, so one of the things that we know is the root of 64 is 8, but that's only half of it because we know that that could also be the root of negative 8 times negative 8 times the root of negative 8 times negative 8. Sorry for my mistake. And so this one would also come out as negative 8. So the truth is that the root of 64 is equal to both positive 8 and negative 8. Okay? And we can shorthand that by calling that plus or minus 8. These are the two values, or the two roots of 64. Okay? I could have said the same thing if I was trying to find the root of, let's say, 4. The root of 4 would either be 2 times 2, okay, or it would be negative 2 times negative 2, because the truth is that 2 times 2 is 4, and negative times 2 is also positive 4, so we would know that the answer is either positive or negative 2. These are our two possible roots. Awesome, let's keep that going. So here we have x squared is equal to 81. Now to isolate x, we have to do the inverse operation. So what is the inverse of x squared? Well, it is the square root. So we're going to find the square root of each of these. Now a square root cancels out a square. They're actually inverse, so they cut each other off. That being the case, we are now at x is equal to, and what's the root of 81? It's 9 times 9, but it's also equal to negative 9 times negative 9. Therefore, we have plus or minus 9 are our roots for x squared. Okay? So following that, we can get to this guy down here. On this one, we're going to go ahead, we're going to isolate x. To isolate x, we're going to divide by 2 on each of these. 2 divided by 2 cancels out, so now we're left with x squared is equal to 50 divided by 2, which is 25, and as we've previously stated, to isolate x, we're going to find the square root of both of these, which would give me x is equal to positive 5 and negative 5. Again, the shorthand way of writing that is plus or minus 5. All right. So now we have multiple things going on here. So the way that we solve something like this is actually we go backwards through PEMDAS. So we want to do inverse operations to isolate x. So going backwards through PEMDAS, we're going to go ahead and see if there's any addition or subtraction we can take care of. There is in this case. So I can go ahead and I can subtract 10 from both sides to isolate x. These two cancel out. I'm now left with 25. X squared is equal to 16. Now, to isolate x, we're going to go ahead and do the inverse operation of multiplying times 25. We're going to divide by 25. These cancel out, and now I'm left with x squared is equal to 16 over 25. And we have to find the square root of that. And the way that we do this, this might have been a while since you've done this, is that we have x is equal to, because remember the square root of x squared is x, and then we have to do the root of 16 over the root of 25. Both of these are perfect squares, so that works out really well. Root of 16 is plus or minus 4. The root of 25 is plus or minus 5. And to finish that out, we would just be left with x is equal to plus or minus 4/5. This would be our answer. Okay, and that's a 4/5. All right. Now down here we have something very similar. Again, we would do it the same way. First thing I would do is I'd subtract 22. I'd subtract 22 from this, and I'd be left with, what am I looking at? 26. So I have 2y squared is equal to 26. Our next step is to go ahead and divide by 2. When we divide by 2, we are left with y squared is equal to 13. And to isolate that out, we have to find the square root of each. I am left with y is equal to plus or minus the root of 13. Because the reason I write it this way is because there is no perfect square of 13. So I'm allowed to leave it inside. And remember, there's two values. Y is either equal to the root of 13 or the negative root of 13. All right, so let's go ahead and take one final step. And this is when we have something like this. Now you've seen this before, and a lot of times we've gone ahead and multiplied this out in the ax squared plus 2ab plus b squared, and then we've done that in that pattern, but we're not going to be doing that today. We're trying to get x by itself, not trying to make it more complex. So instead of multiplying times 4, we're actually going to do the inverse, which is dividing by 4. So we're going to divide by 4 on both sides. Canceling those two out, we're now left with x plus 6 squared is equal to 32 divided by 4, giving us 7. So, giving us 8. What am I talking about? It's 8. So then, like we have done previously, to get rid of the square root, to get rid of the square, we have to do the inverse operation, which is the square root. So now we're at x plus 6, because this square root cancels out the square. They're like blah, blah, all right? And so now we're equal to, x plus 6 is equal to the root of 8. And remember that we're continuously calling this the positive and the negative root of 8. But I can actually solve out the root of 8 a little further, so let me do that. I know that we have x plus 6 is equal to, and I can break apart the root of 8 into 2 times 2 times 2. Now the way that square roots work is that we're trying to find doubles, so these two will come out as a single 2, and we still have a 2 left inside. So now we have plus or minus 2 root 2. And to finish this out, we have to isolate x. So I'm going to go ahead and I'm going to subtract 6 from both sides. All right? And these two cancel each other out. So I'm left with, at the very end, x is equal to, because I've isolated it now, negative 6 plus and minus 2 root 2. Okay? Remember, this is two different values. It's x is equal to negative 6 plus 2 root 2, and it's negative 6 minus 2 root 2. All right, so that is the basic idea of, the very fast idea of solving using square roots to solve quadratics. All right, next, coming soon after this, is going to be using the quadratic formula. Thank you so much. I really enjoyed talking to you today. Have a great day. Peace!